Hi guys, in this video we're going to look at a mathematical explanation for investigation 5, which talks about the effects of changing a data set by adding a constant value or by multiplying by a constant value. So first of all, let's begin with a data set. We're going to make it as general as possible. So we have, let's say, n data points. So x1, x2, and so on until x sub n. Okay, so this is n data points in a data set. And we have the mean, which is the sum of the data from 1 to n, and we divide by the quantity of data, which is n. And of course, we also have the standard deviation for the population, which is the one that we use, which is to take each data value subtracted by the mean, raise it to the power of 2. We're going to do the average of these numbers. So we're going to add them up and then divide by n. And remember that we take the square root for the standard deviation. Without the square root, it's the variance. Okay? Alright, so now let's look at what happens when I add a constant value to every member of the data set. So let's say that we're going to add c. So we have x1 plus c, x2 plus the constant c, and so on. Okay, x sub n plus c. So let's calculate the new mean. The new mean, again, is going to be the sum from 1 to n of the new data members, and we divide by the quantity of data. Alright, now we can split this sum. Remember that the addition is associative and commutative and all those good properties that we know from primary. So we can split it like this. So the sum of the data plus the sum of the constants divided by n. Alright, and this is a fraction. Well, okay, so using some of the properties of fractions, we can split this sum like this. Alright, now the first term here is the original mean. And the second term, if we add c n times, then that's going to be n times c, because we're adding c n different times, one for each data member, and we divide by n. Of course, we can cancel these n's, and in the end we get the original mean added to the constant c. Okay, so now let's look at the effects of adding the constant to the standard deviation. So if we do the calculation for the standard deviation, we're going to have the sum of I from 1 to n, okay, and then we have the data, the new data, x sub I plus c, and then minus the new mean, but the new mean is x plus c, okay, and then we are going to raise it to the power of 2 and divide by n. Now what happens, notice that if we do like terms, then we're going to have plus c minus c. So these two terms cancel out. And after I cancel them out, notice that I'm just going to have exactly the same formula as the beginning. xi minus the mean squared over n. Well, I did it without the square root, so this is actually the variance. Okay, so it's exactly the same formula. Of course, you would take the square root for the standard deviation. So this is the same original variance. Alright, now let's take a look at what happens when I multiply all of the data members by a constant. So I'm going to multiply the constant d to each data point. So d x1, dx2, and so on until dx sub n. Alright, so let's calculate the mean. We need to take the sum of all of the data members. Now remember that, well, notice that this is actually like dx1 plus dx2 plus dx3 and so on. And notice that d is a common factor. That means I can factor it out like this. Okay, so that's what I'm going to do here with the symbols. Alright, so what I'm going to do is factor out the constant. So that's going to come outside of the sum. So it's going to be the constant multiplied by the sum of the variables over n. And of course, that means that this is going to be the constant multiplied by the original mean. Okay? So this part is the original mean. All we did was factor out the constant. Okay, now let's look at what happens with the variance and the standard deviation. So let's calculate it. Again, we're going to take the sum of all of my data members. And now we have dxi minus dx bar, which is the new mean for the transformed data, to the power of 2 over n. So here we can also find a common factor, but it's raised to the power of 2. So when we factor it, it's going to come out with a power of 2. And then we're going to have xi minus x bar squared. Okay, over n. So again, this is the variance, right? So now notice that d squared is a common factor for the sum, the same way that d was a common factor for the sum in the mean. So we can factor out d squared from this sum, and it's going to be multiplied by by the sum of all the data members, or of all the differences here, over n. And notice that this is the original variance. Okay, so when I multiply a constant number by when I multiply a constant to all of the data members of a data set, then the variance gets multiplied by the square. Okay, now remember that the standard deviation is taking the square root. Okay, so for the standard deviation, we would take the square root, and we would have the square root is just d sigma. So it's the original standard deviation multiplied by the constant. Okay, so the variance gets multiplied by the square of the constant. The standard deviation gets multiplied by the constant, because of course we take the square root of the variance to find the standard deviation. Okay, so let's look at a quick summary of what we looked at in this video. So the effect of adding a constant to every member of a data set on the mean is that the mean will also be added by the constant. The standard deviation remains unchanged, and the variance is also unchanged. Okay, now what happens when we multiply a constant to every member of a data set? The mean is also multiplied by the same constant, and the standard deviation is also multiplied by that constant. The variance, however, is multiplied by the square of that constant. Okay, so that is the reasoning behind the effects of changing a data set by a constant. Till next time.